Hey everybody, here is the video for the first half of Pythagorean Theorem and Trig ratio. So we're just going to cover this first page here, which is just going over Pythagorean Theorem. Just a reminder, we did cover how to rationalize a denominator as well as how to simplify a radical in general in the last couple lessons because we need those skills for finding the answers for this one. So if you're still a little rusty on those, I would look back over those notes before you go over this. Up at the top here, we have a picture that says hypotenuse, legs, and then a little thing that just talks about how for the right triangle, you use the Pythagorean theorem. A couple things I just want to remind you of. The legs A and B, it doesn't matter which one you call A, which one you call B. And the hypotenuse, which is the longest side, is always across from the right angle. Write that down. Hypotenuse, always across from right angle, which is that little box. Or square, whatever this thing. Good. Now we're just going to practice finding the third side. These are all in general, same kind of questions. On all of these, I do want you to write down the rounded answer and the exact answer in simplified form. Some of them will only have an exact answer because they are exact, like whole numbers, but a couple of them will have both. So we're going to put both on here. On our practice, it'll specify which one it's asking for. So look at this first question here. It says, find the third side of the triangle. And then it gives us two sides, 3 and 7, and we don't know the third side. So as you can see, if I put my little arrow here, I'm looking for the side across from the right angle. So this has to be C. That means these are A and B. Doesn't matter which one you call A, which one you call B. And to find C, I'm just going to plug it into the Pythagorean theorem. So I have A and B, 3 and 7. So I have 3 squared plus 7 squared equals C squared. And what I would do is just type this part into the calculator. Go ahead and do that. Here we go. Well, here's our calculator. Let me zoom out there. 3 squared plus 7 squared. And that is 58. There we go. And then I want to get C by itself right now. It's being squared. The undo of that is to take the square root. And I would get C equals the square root of 58. Now, I don't know if this is the exact answer. Well, I know this is value-wise the exact answer. I'm not sure if this is the most simplified answer. So what I'm going to do is what we did last week is see if 58 is a perfect square or if it can be divided by any perfect squares. So I got 58 here. It's not a perfect square. A 64 is the closest perfect square. So I'm just going to see if it'll be divided by any perfect squares. I'm just going to go with my list, which I do have in my head. You can also write it up here at the top if you want to. That might be helpful. I'll go do that right now. I'm just going to go to 12 squared because we won't need anything bigger, I don't think, for this assignment. So looking at 58, I'm going to divide it by all the ones that are less than 58, starting with 36 and working my way down. I'm looking for a whole number. Okay, none of those divide in evenly. So this is a simplified response. This would be the exact answer. It could also be phrased as the simplest radical form answer. And then for the approximate, we'll just actually type into the calculator, what is the square root of 58, and then just round. We got 7.615773106. I'm just going to round to the hundredths place, so 0.62. And that's how you do it. Hopefully this feels like a review from geometry. Let's try one more together, and then you can try the other ones. Looking at this next one here, I have the hypotenuse this time. I know that C because it's across from the right angle. So I'm missing one of these. I'm just going to call it A because I feel like it's on the left side. So I got A squared plus B squared, that's 18, equals C squared. And I'm just going to solve for A. I personally like to move it first before typing in the calculators because I think it's faster. So I got A squared equals, I'm going to put this whole thing in the calculator. So I got 33 squared minus 18 squared. And that is 765. Now to get A by itself, take the square root. So A is the square root of 765. I don't know if this is a perfect square. It is much bigger than our list. So I'm going to Google it. I'm going to type it in my calculator. There we go. It's not a perfect square. It's 27.65863337. What I'm going to do now is see if I can simplify this by breaking into two other numbers that multiply to make 765. And one of them is a perfect square. So I'm just going to divide it, 765, by my perfect squares. Just a reminder, we can check to see if we divide it by 2, that tells us how big it could be. So we're looking for any perfect square that's less than 382.5. I don't know all the ones up to 382.5 off the top of my head. So I'm just going to go with our list and see if we can find something from this. And if we can't, we'll try something bigger. We get close there. Oh, there we go. 9. 9 times 85. Okay, and then the square root of 9 is 3. So 3 times the square root of 85 should be our final answer. We can always double check. I'm not 100% sure if 85 can be divided by any of these. I don't think it can. Just to make sure we didn't miss like a bigger number that we didn't know. So you could just go through and double check all the ones that are smaller than half of 85. But I think we're good. Okay. 9 and 4. Yeah, we're good. So here's the exact answer, or they're going to call that the simplified radical form. And then our approximate answer, we're just going to type in square root of 765. It was 27.658. So I'm going to round to 27.66. There you go. And that's how you do it. So go ahead, pause, do the other three, and then come on back. Here are our last three answers. For this one, we had the square root of 289. That was bigger than our list. We had to check if it was just a perfect square, and it was. It was the square root, or the square root of it was 17. That means this is our exact answer. There is not an approximate because it is an exact number, so we're good with that one. Here, same thing. We had an exact answer of a whole number 5, so there is not an approximate because there's just one answer. The way I got this one, I think some people might have tripped up, but during class right here, make sure, remember, we're squaring the entire thing, not just that square root of 5. So I just typed this whole thing in the calculator. Oh, whoopsie, sorry. There we go, whole thing in the calculator. And that got me 25, then I took the square root because I was trying to get b by itself. And then lastly, we had this one. This one was an approximate and exact answer. Here is our simplified radical form, and then our approximate answer. I was looking for C. Here's what I got here. And then 10 squared plus 80 squared, or square root of 80 squared. This I put in the calculator, and it told me 180. I took the square root of 180. It was not a perfect square, so I simplified. It could be divided by 36. That gave me 36 times 5. 36 squared is 6. That got me 6 squared of 5. And then I just typed this in the calculator. It told me it was 13.41640,786. I rounded 13.42. And that's how you do it. And then lastly, on this page, we found these guys here. Really, we just filled it in. You were taught SOHCAHTOA back in geometry. I've also written it here with the division on it. I also here have tiny little triangles to help you learn. The biggest issue I see people have to make the topic inaccessible or not able to do the topic is not understanding opposite versus hypotenuse versus adjacent. So I have our triangles here showing you if you're looking for this angle, how to know which one's which. And then if you're looking for this angle, how to know which one's which. Easiest way, in my opinion, hypotenuse is always across from that right angle, and then your adjacent side and your hypotenuse always make your angles. Your angle is always made up of these two. That means the opposite one is always the one that you don't touch at all. That's how I like to remember it. But filling in here, our sign, or the SO of SOHCAHTOA. we write it like this, sine of theta. And it is the opposite side divided by the hypotenuse. And then we also have some reciprocals. That just means you flip it over. So it's 1 over the sine, which makes it flip to hypotenuse over opposite. And then same thing goes for the other one. So we have cosines, our next one. It's the SOHCAHTOA. Well, I guess SOHCAHTOA. So cosine of theta is A over H, or adjacent over hypotenuse. Secant is the reciprocal of cosine, so 1 over cosine, which means we're just going to flip it over, so hypotenuse over adjacent. And then last but not least, we have tangent. Tangent's the only one that doesn't use the hypotenuse. So tan of theta is actually the sine of theta divided by the cosine of theta. And when you write those as fractions like these, if you like work out the math, it ends up being the opposite over the over the adjacent, because the hypotenuse cancels out. And then cotangent is the reciprocal of tan, so 1 over tan. You could also look at it as cosine over sine, or as adjacent over opposite. And that is all we're going to cover. If you want to pause and finish writing these down, you can. I'm never going to ask you to memorize these. It is a lot easier if you do memorize them, but I will always provide you with the ratios. They're on the sticker on the back of your journal. So there we go. Nice talking to you. Bye. Hey everybody, here is the second half of the trig ratio and Pythagorean theorem notes. We're going to actually go over the trig ratios on this one. Up at the top of this page, I am going to write down my SOHCAHTOA just so I don't have to keep flipping back and forth. I know on your page you can just look back and forth, so if yours you want to keep it, you can. On these questions, it will always specify if it wants you to round or if it wants the exact answer. And just a reminder, we did go over how to do this kind of stuff. So how to get a rational denominator, aka cross out the radical in the bottom, end up with that one. And then how to simplify our radicals previously last week so that we could be able to do questions like these. That's why we went over it in the first place. So let's go over this first one, and then you can try another one. It says, find the tan of x rounded to the nearest hundredth. So I'm looking for tangent. Tangent is TOA. So I'm looking for a tan of x. That would be the opposite over the adjacent. So to be able to do that, you need to know which one is the opposite and which one is the adjacent. So let's look at x. It's right here. Easiest way to remember. The easiest one to know is the hypotenuse. It's always going to be across from the right angle. The second easiest one to remember is the opposite side. It's the one that doesn't touch your angle. My angle is here. I'm not touched by this number over here because that's the opposite number. And that would make this guy our adjacent one. Your angle is always composed of the adjacent side and the hypotenuse. So the opposite side is always the one that's not part of your angle. Let's go ahead and write what we got. So we got opposite, which is 12, over adjacent, which is 5. Normally this would be our answer because it's a fully simplified fraction, but this says round to the nearest hundredth. So I will type this in the calculator. And the calculator tells me 2.4. I'm going to put 2.40 because it did ask for a hundredths place. I didn't have one because that was exactly 2.4. So that's how you do it. Pretty straight and simple. Go ahead and see if you can figure out the next one. And then come on back when you're ready to check it. Here is number 2. I was looking for the cosine of z. Cosine is cos, so COHCAHTOA, or chi. I was trying to say cos. Well, anyways, it's right here. Adjacent over hypotenuse. First thing I'm going to do is circle my angle that I'm looking at. I'm looking at z. And then the easiest one to identify is the hypotenuse. It's across from the right angle. Second easiest to identify is the opposite. It's the one that doesn't touch our angle. Your angle is always going to be composed of the hypotenuse and the adjacent side. So the opposite side is the one that does not interact with your angle. That would make this one the adjacent side. Now, adjacent over hypotenuse would be 21 over 35. It asked for the fraction in simplest form, so we couldn't leave it like this because they can both be divided by 7. And that gives me 3 over 5. Go ahead and try the next one. Here is our answer. You're looking for the cosine of D. I circled D. I identified my sides. Hypotenuse is across from the right angle. Opposite does not make up my angle. Hypotenuse and adjacent do make up my angle. And then I got to here. It asked for nearest hundredth. I wanted to round. So I typed it in the calculator and it gave me 0.40. So I added a 0 on there because I wanted a hundredth place. Good. Let's go to one that actually requires math. Looking at the next one here, we'll do this one, then you can try this one. It says, find the exact value of the sine of t in simplest radical form. That means there's going to be a radical maybe in the answer. And we want to make sure we're fully simplified. So SOHCAHTOA, the sine of t equals the opposite over the hypotenuse. I'm going to circle t. The opposite side is over here, not touching my angle. And the hypotenuse is the one that is across from the right angle. That gets me to here. This could be our answer, but it's not because square root of 20 could be simplified, and we know that because we practiced this last week. So what I'm going to do is see how I could simplify the square root of 20 by dividing it into a perfect square and another number. And a perfect square that goes into 20 is 4. So that would turn into this. The square root of 4 is 2. And then I could simplify here. 2 goes into 2 one time. It goes into 6 3 times. So my sine of t is the square root of 5 over 3. And there we go. That's how you do it. So the reason we learned how to do this in the first, well, we reviewed it so you could do questions like this. That was our goal. Perfect. Go ahead and try these next two. The sine of g and the tangent of d. Just a heads up, tan of d is going to have a radical in the denominator. And you're going to have to multiply by an equivalency of 1 to get that radical out of the denominator. So try these two and then come on back when you're ready. Welcome back. Here are our answers. So for the first one, the sine of g is 5 square root of 3 over 11. You got that here by simplifying square root of 75. And then tan of d is 17 square root of 2 over 12. This one, like I said before, does have a radical in the denominator originally because looking at d here, our opposite side was 17. Our adjacent side is the square root of 72. And to get rid of that, we multiplied by an equivalency of 1, which is square root of 72 over square root of 72. That gets rid of our radical in the bottom. And then we see if we could simplify this. We could. It is 36 times 2. Square root of 36 is 6. That gets me to here. And then I could still simplify again. 6 divided by 72 is 1 over 12. And that got me to there. The last two here are very simple mathematically because I want to make sure you understand how to use the reciprocal ones. Looking at these, we have an exact value in simplest form for both. It's looking for the cosecant of v. So looking over here, cosecant is the reciprocal of sine, so it's hypotenuse over opposite. Remember, I'm never going to ask you to memorize these. They're in your journal, as well as with a sticker on the back. And the last one was cotangent, which is adjacent over opposite. Okay, so go ahead and try those and come on back. They're real quick. Here are the answers for those two. The cosecant of v was 13 over 5, which could be simplified. Same thing for the cotangent of b. It was square root of 21 over 2. Neither of those could be simplified either. Those are the answers. Perfect. Hope this helps. See you later. Bye.